Hi friends, in this tutorial we are going to discuss a very important concept called confusion matrix, and the name itself it says confusion and it's very hard to understand. Okay, so the first thing, remember, confusion matrix is used to check the performance of the model, which are classification type of model. So first, in this video we will discuss about the confusion matrix, and we will discuss about these terms called true positive, true negative, false positive and false negative. Okay, let's start it. First, understand what are the classification type of model. Classification type of model is basically where you classify through the model if something exists or something doesn't exist. Let's take the example of a model which detects a cancer disease. Okay, so in the output you will see whether a person has got cancer or that person doesn't have the cancer. Okay, so these type of model which gives you the response in binary form, okay, in the form of yes or no. These type of models are called classification model. And if you want to measure the performance of your classification model, how good the model is predicting, you need to understand these terms: true positive, true negative, false positive and false negative. Then you can measure the model performance. Let's understand. These are very confusing words, but I will give you a trick. Okay, remember, true positive, the last word, positive negative, it means it says about the model. Okay, how the model is predicting. Okay, so when I say true positive means the model is predicting correctly positive and actual result is also true. Okay, and same way true negative, the model is responding again negative and actual result is also negative. Here the model is saying positive but actual result is negative, and here the last word is negative. So again the model is saying as negative but actual is positive because it's a false. Okay, so let's understand with one example. So if you see here what I have explained, that's what we have written here. True positive model predicts positive and it is actually a positive because it's a true. Okay, the first one is the real data. Okay, the last one is the model performance. Okay, second one again, model says it's negative and actual data is also negative because it's true, right? Here the model says positive, okay, but actual data is says it's negative. Same way the model says it's negative but actual data says it's positive, it's opposite, it's a false. Okay, let's understand all these four terms with one example. Okay, before that, this is the confusion matrix. Okay, when we write it here this way it's called actual, and this way it's called predicted values. Okay, so suppose let's say we have a example where our model is predicting a cancer disease. Okay, so here this is the way we will create the confusion matrix. Okay, this side it will be actual, this side it will be predicted. So this is the sample set of data. A disease test of 100 people. How many people are there? 100 people. 40 people have the disease and 60 do not have the disease. This is the real data. Okay, 40 people have disease, 60 people do not have disease. Okay, so when we say actual, so this row sum should be 40. Okay, because these are the 40 people who have the disease. Okay, and 60 people who do not have disease. Again this is the actual, this should be 60. Okay, and again here we are doing the model prediction. Okay, here this one the model has predicted positively and here the model has predicted incorrectly. Okay, so if you see here this particular thing where which we said the model is predicting positive and data is also positive. So what it is? It is true positive. Okay, the model is predicting negative, okay, and data also says it doesn't have any disease. Okay, So this is again true negative. So true positive and true negative means your model is exactly doing the same thing what data says. Okay, here it says the disease is there, okay, because it's actual. Data says positive, okay, data says true, the first letter, okay, so it's a true positive. And here the model says negative and data also says it's a negative. Okay, next one, these two important thing. Okay, false negative and false positive. What is this? Okay, so here again the model says there is no disease, okay, predictive negative, but data says it's a positive. Means data says you have got the disease, but model says you don't have the disease. Okay, and similar way the next one, the data says the model says it's a positive, means uh, and the data says person doesn't have any disease. Okay, false positive. So remember, false positive and false negative are the scenarios where model got it wrong prediction. Okay, so let's put it over here in this matrix. 40 people have the disease. This is the real data. Okay, have the disease. So this row should be 40. Okay, 60 people do not have disease. This is the negative data. 60 people do not have disease. Okay, now let's come to the prediction. 35 people are correctly as positive, means this one, actual data positive and it predicted also positively, 35. Okay, 5 people miss, means it did not predict properly, you put it over here. Okay, similar way, 50 correctly predicted negative, this one true negative, you put it here. Okay, and remaining 50, because it has to be 60, it will basically became as 10. Okay, so hope this confusion matrix is very clear to you. Okay, again this row will be the actual data row which is positive, this row actual data row which is negative, this row the model performance, the model predictive positively, this row the model predictively negatively. Okay, and remember these words I gave you a trick: true positive, true negative, false positive, false negative. The last word is always corresponds to model and the first word always corresponds to the real data. Okay, and using confusion matrix you can basically tell 4 parameter of the performance. Okay, model accuracy, sensitivity, precision and F1 score. Okay, so if you have to evaluate any type of a classification model, like you want to predict a disease, or you create a model where you want to see whether any email is a spammed email or it is not a spammed email. Okay, so such type of classification model where you are predicting in binary a true or false, yes or no, you need to create a confusion matrix and you need to have these 4 parameters to check the model performance. I'm not getting into all these 4 parameters. I have created a separate video and you can look into that, what is accuracy, sensitivity, precision and F1 score. Okay, if you have any doubt or any question in confusion matrix, please ask a question below. Thank you.